Cooking with Chemists!
Good morning and welcome to Cooking with Chemists.
Today we will be discussing limiting reagents and colligative properties.
The first thing we'll be making is chocolate chip cookies. In order to begin, we have to look at the recipe.
I'm now going to add the first three ingredients: flour, baking soda, and salt. Because there is so much more flour than there is in baking soda, it seems that the baking soda would be the limiting reagent, leaving excess flour.
This isn't true though, because the ingredients follow the ratio in the recipe. So we just saw the recipe, and as long as the ratio stays the same, there is no limit. If there was too much flour, the cookies would be bad and crumbly.
And if you were to add 1 more teaspoon of baking soda, the flour would be the limiting reagent, leaving extra baking soda behind.
Now, we're going to add the rest of the ingredients.
Oh wait. Spoon.
Oh, there you go. Why'd you put in more sugar than the recipe calls for?
Well, I wanted to make sure that the eggs were used up and did not limit us, because if there were eggs left over, someone could get salmonella.
Good idea. Alright, I think we're done and we need to mix them. Alright, I think we're done and ready to roll them out.
What are you thinking?
I'm thinking I really want to eat these cookies.
No, I mean the spoon. You didn't scrape it off, so now we won't make as many cookies. That totally messes up our percent yield.
Percent yield? What does that mean?
It is the percent comparing how much you made and how much you should have made.
Percent yield equals actual amount that you made divided by the amount that you should have made times 100.
We lost some cookies because you didn't scrape off the spoon.
Well, we're going to take a quick break now, but we'll be back in a minute.
And we're back with Cooking with Chemists.
Next on the menu are popsicles. We have some juice and some water here that we will use to make our popsicles.
In order to make the juice, we must add juice mix to the water, and these particles will lower the freezing point.
How will we know the freezing point changed?
Well, if the freezing point decreases, it will take longer for the juice to freeze than the water.
Let's try it.
Alright, you grab the water, I'll grab the juice. Going into the freezer.
Heavy threes.
Go fish.
Guys, it's been 20 minutes.
And we're back. It's been 20 minutes, so let's check on our juice and our water. You'll see here, the juice, there's a little bit of ice forming, but it's not really frozen yet. But look, the water has frozen. You see, the particles in the juice get in the way of the water molecules as they try to bond together to form a solid.
I have learned so much already. What are we going to do next?
You'll find out after this commercial break.
And we're back with Cooking with Chemists.
We have already made yummy cookies and refreshing popsicles, so now we're going to make hot chocolate.
Here we have a cup of cold water, and Michaela's pulling out some boiling water from the microwave. And over here we have 2 equal amounts of hot chocolate mix.
When we mix the hot chocolate mix into the cup of cold water, some of the hot chocolate will dissolve into the water, and some will be left over on top.
we add it to the boiling water, all of it mixes in and dissolves. This is called a saturated solution.
When we add more and more hot chocolate mix until it can't dissolve anymore, this is called supersaturated. If the hot chocolate were to cool down, the hot chocolate mix would crystallize.
Let's look at the boiling hot chocolate. Because we added hot chocolate mix to the water, the particles are getting in the way of the bubbles that are trying to form a gas.
This increases the boiling point, just like the particles decrease water's freezing point.
Well, it looks like we are out of time for today. We've covered limiting reagents and how to use and find the mole-to-mole ratio.
We've also discussed percent yield.
We took a look at the colligative properties and how the presence of particles can change the freezing and boiling points.
Thanks for watching, and we hope you enjoyed this episode of Cooking with Chemists.
Bye!